Okay, our next topic in class will be half-life. This is a video to help you if you want to jump ahead. These are the notes that I'm going to introduce to you for half-life. There's some key points. Half-life is just another application. It's another situation, kind of like compound interest. But half-life refers to something that's a little more scientific. So the best example for half-life is radiation decay. So after, for instance, when the nuclear bombs in Nagasaki and Hiroshima during World War II, when those went off, they used what we call radiation. They were radiation bombs. Half-life is radiation decays in a very interesting way. If, for instance, the half-life of a certain radiation is 1 day, that means in 1 day the amount of radiation will be half. After 2 days it'll be half of that, and then it'll continue to go down. So we're going to model this using the same exponential model that we always use. Okay, A is our initial amount, so how much of that radiation did we start with, or bacteria. So this is still our initial value. And B, because we're talking about half-life, we want to know when the amount is half, and when half of it's left. B is always going to be 1/2. You never have to worry about finding a rate for half-life. It is always 1/2. It's really easy to find. Okay. The variable that we're going to want to know is x. So here's another key about half-life. Because we're continually taking half of half of half of half, we'll never get 0. We'll always have some level of radiation or some level of bacteria, but it'll never get 0. If you're only taking half away each interval, you're still left with at least half of what you started with. So, definition of half-life. The term half-life refers to the time it takes for half of the atoms in a radioactive substance to decay. So I try to explain that in a little bit different way. So in this particular way of writing it, it's the same as our exponential model. We're just using different variables. But see, you have our initial amount, it's just A naught. Like compound interest, it was P. P is our principal, or the amount we start with. So the initial amount we start with is still the same. It's outside our parentheses. So this is the split factor. After a half-life, 1 pound becomes 1/2 pound. So basically, B is going to be 1/2. Alright? Here's the part we're interested in, the exponent. So T again represents time. So how much time has passed? So is it 6 years, 7 years? And if a half-life is 1 year, then it would go in for age.